Thank you so much for the invitation to speak this evening. It's a real pleasure to be here. So I'm going to be talking to you about the Tactile Universe project. It's a project based at the University of Portsmouth, which is a UK university. My role in that university is an outreach and public engagement fellow. So most of my job is science communication. But my background, my motivation for a lot of this is that I'm also somebody who is blind. So I've had a vision impairment since birth, but I've also had a lifelong passion and interest in astronomy. And I eventually got my PhD as an astronomer, but it wasn't always straightforward. And so, yeah, a lot of the work that we do as part of this project is to make astronomy more accessible to people who are blind and vision impaired, just to make all of that a little bit easier. And so what I'm really going to be focusing on today is how we've been able to draw on the expertise of the blind and vision impaired community to make our resources really accessible, make sure that they really work for that community. And I'm also just going to tell you a little bit about what kind of context we use those resources in, and hopefully show you how you might be able to adapt some of those resources yourself. Okay. Oops, there we go. So I always start these talks off with a statement, and that is that astrophysics is really perceived to be quite a visual science. So astrophysics and astronomy, I think I would argue, is probably one of the more visual sciences out there. It's all about observing things, observing the universe, looking through telescopes, all kinds of stuff like that. For that reason, it can appear to a lot of vision impaired people to be a subject that is very difficult for them to access. And that's not just because it's very visual in nature, it's also because a lot of the language that we use around astronomy to describe things, the analogies that we use are also really, really visual. They're things that can be quite difficult for somebody who's blind or vision impaired to relate to. And so for that reason, yeah, a lot of people who are blind or vision impaired don't really access astronomy as a subject to be interested in. But also the number of people who go on to become professional astronomers who are blind and vision impaired is really, really small compared to the overall population. So our solution to this is the Tactile Universe project. And so it's a public engagement project that we started back in 2016. And we use tactile representations of real astronomy data to make current topics in astrophysics research more accessible to members of the blind and vision impaired community. And so the main goals of the project are that we want to work with the vision impaired community to develop accessible resources for learning and research. We want to help build interest and build the aspirations in young people in the subject of astronomy. We also want to demonstrate to other science communicators and researchers that there are more accessible ways that they can communicate their science. And last but not least, we always want to show that accessibility helps everybody. So even though you might set out to start making something accessible for a particular audience, by making that thing more accessible, you're actually probably helping everybody. You're making your science easier to digest. You're making your resources easier for everybody to use. So in astronomy, we often show beautiful pictures of space like the one I've got up here on the screen. And so this is an image of a galaxy. So galaxies are these massive collections of stars and gas and dust, all held together by gravity. This is a spiral galaxy, not too dissimilar to our Milky Way galaxy, the galaxy that our sun is part of. And you can just see, looking at this image, that there's a striking amount of detail. So we can see the bright core. We can see these beautiful spiral arms winding out from the center. You can see the gas and the dust is sort of forming almost these feather-like structures as those arms sort of spiral out from the middle. And you can see as well that there's a lot of color variation here. So there's a lot of detail. And so you can imagine that without a really, really detailed description, this image is completely inaccessible to somebody with low or no vision. It's a really, really difficult thing to describe, and it's a really, really difficult thing to appreciate. And so we came up with a really, I guess, simple solution to this kind of problem. So on the left-hand side here, I have that same galaxy. It's an image taken with a telescope. And on the right-hand side, I have a tactile surface. And so the way these tactile surfaces work is we take the brightest pixels and we make these the most raised part of our tactile surface. We then take the darkest or blackest pixels, and we make those the lowest point in our tactile surface. Oops, my camera's doing something weird. Give me a second. Okay, sorry about that. We then take all the gray pixels and we scale those in between the black and the white pixels. And so what we end up with here is basically a tactile analog of an image. So where your eyes would look at the image and see this change in brightness and use that to sort of build shapes, we can use the tactile surface in the same way. So by running our fingertips across the surface, we can feel which parts are bright, which parts are dim. We can feel those shapes and we can build an overall picture of what our eyes would be seeing. Okay, so we came up with this really simple idea, but we realized very quickly that it was going to be really important for us to work quite closely with the blind and vision impaired community to make sure that this idea that we come up with was actually properly implemented. The reason it's so important to work with the community that you want to develop resources for is because, particularly for people with disabilities, there's no one size fits all when it comes to accessibility solutions. Everybody has slightly different needs. And if you don't make your resources versatile enough, they won't actually work for everybody that you want them to work for. It's really important to remember that the members of the community you want to work with are actually their own experts. So they're the ones who really know what they need. They're the ones who can tell you what they need. And so it just makes sense to actually talk to the members of the communities you want to work with, draw on their expertise, draw on their experiences, and this will actually make your resources much better. And I'm going to show you how that actually, that process sort of worked for us. So initially, we printed our tactile surfaces with lots of different tactile heights. So some of the tactile heights are quite tall, quite sharp. Some of them are quite shallow. We wanted to find out what tactile height worked best for the largest number of people. So we wanted to get feedback based on how sharp things felt, whether people could actually detect the differences in brightness. And so we presented people with a whole lot of different options and basically got feedback there. Early on in the project, we also ran pilot events where we took our models out, worked with the community, practiced ways of explaining what these models were showing, and tried to develop language that was slightly more accessible. So we tried to move away from those really visual analogies, those really visual descriptions, and we tried to find things that would be more relatable to people who are blind and vision impaired. And so we actually ended up with models that look quite different from that sort of original example that I showed you. And I'm going to go through the things, the features, I guess, of those models and how those were sort of informed through consultation with members of the blind and vision impaired community. So the model size ended up being really, really important. The models themselves are around about the size of a postcard. That ended up being a really good just size for those models because they're easy to handle with one or two hands. You can pick them up, you can lay them down flat on the table. It's not so big that it's unwieldy. It's just, it makes the models a lot easier to work with. It also means that the models aren't so big that somebody who's relying purely on the tactile features won't get lost in the detail. We found that with bigger models, people were having much more trouble building an overall mental picture of what those models were trying to show them. We also settled on a tactile height of 3 millimeters. This was just the right height so that people could feel that change in brightness. They could feel those shapes in the models. But the features weren't so sharp that they were hurting people's fingers, and they weren't so shallow that people weren't able to detect things. And so in this context, the tactile feel is actually really, really important. If the models don't feel good, people won't want to use them, and it'll actually turn people off. So making sure that the models actually have a really pleasant tactile feel was a really important part of this process as well. On the front of the models, you probably notice that we have a tactile nameplate. So we put that there so that people have a quick and easy way of identifying what model they're handling. And it also gives people a common frame of reference, so a way to orientate the models. We also put a raised border around the edge of the models. This came from one of the people we work with saying that they wanted some way of knowing how bright any feature in the model they were touching was. And so this border is the same height as the brightest part of any of the model. And so you can imagine people could sort of bridge their hand across. They can use that border as a reference frame to work out how dim or how bright any part of the model they're touching is. Then if we flip the models over, when we were talking to, again, to the people that we consulted with, it became very apparent that the people who had some usable vision, so even people who are vision impaired who can see a little bit, wanted some way to use that little bit of vision they had to interpret these models as well. So what we've actually done is we've put the image that we use to make the models on the back of the models, and we've mirrored that. So what that means is if you have some sight, you can look at the back of the model and you can feel the corresponding tactile features on the other side. And so that just gave people an extra way to interpret these rather than just using tactile. We decided that incorporating some visual elements into the models was actually going to be really beneficial for people as well. Okay. Along with all of this, though, of course, using the right language to talk about these models is also really, really important. So just like you would never show somebody a picture of something without describing it and just expect them to understand, we also had to be really careful that the language we use to talk about these models is also accessible. So one really good example here is obviously the images that we look at in space, the ones that groups like NASA publish are often full color. And color can be a really difficult concept for somebody who's totally blind to understand. If somebody's never had vision, color isn't something that they can necessarily relate to. But in astronomy, we can actually often link color to really physical concepts. And so in the case of these galaxies, if we're looking at parts of the galaxies that are blue, that's usually where there are lots of young, hot blue stars in our galaxies. And if we're looking at parts of the galaxies that are red, that's usually where there are lots of older, cooler red stars. So making sure that if we talk about color, we have a really strong link to a physical concept, we can make that color relevant in the context of those images. We can also be a little careful about the analogies we use to describe shapes and concepts. So one example is it's really tempting to talk about, say, the galaxy that I've shown you as a whirlpool. It looks like a whirlpool. But a whirlpool isn't something that you can reach out and touch. So for a totally blind user, a whirlpool is still a really foreign concept. We can find things that can be touched that are spiral in shape, and so we can use those as analogies instead. But we can also talk about things like clouds to describe sort of the way a galaxy is put together. You can think of clouds of stars, clouds of gas. And in fact, a cloud is something you can walk through. If you've ever been out on a foggy morning, on a cold day, you probably walked through a cloud. So it's a more tangible way of sort of talking about these types of things. Okay, so lastly, what I want to do really quickly is just talk to you about how we use these models in a practical sense. So in 2018, we were awarded some funding from the Science and Technology Facilities Council to basically turn these resources into workshops that we could use with young people who are blind and vision impaired to inspire them with science and to help them access subjects that they might have had difficult accessing in the past. We also wanted to make all of our resources available for free so that anybody with a 3D printer could download them, 3D print them, and use them in their own classrooms or classroom settings. So to make sure that these models were going to work and to make sure that our workshops were going to work for this audience, we went into schools, we did lots of testing, we talked to students, we got their feedback about what was going to work for them and what wasn't going to work. And we settled on the following. So with young students, so students who are in upper primary school, we run workshops to do with the solar system. The reason we start with the solar system is because it has more relatable scales and sizes than something like a galaxy. It's a little bit easier for people to wrap their heads around how big things are in the context of our solar system. So we run activities where we present students with a number of common objects. So things like peppercorns to represent the Earth, things like tennis balls to represent Jupiter, and a giant beach ball to represent the size of the sun. And so we can build up this idea of scales of the different planets and objects in our solar system. We then get students to plot the solar system on a long strip of paper where the separations between the planets are to scale. And so all of the inner planets are really close together. All of the outer planets are really, really far apart. For the vision impaired or totally blind students, we get them to plot this using little rhinestone stickers, so little jewel stickers, so that they can run their fingers along the strip of paper and feel those separations. Once we've talked about the solar system, we can then start to build up larger scales and larger distances. So we use tactile models to talk about what the night sky looks like, the fact that it's just this patchwork of dotted stars. We then expand our scales a little further to talk about how we view our Milky Way galaxy as this long strip of light stretching across the night sky. And then we get students to build their own model of a galaxy using a CD and some Play-Doh. So our galaxy is shaped a bit like a disc. It has a little bulge in the middle and it's got these spiral arms that stretch out. And we can use this process to actually help students understand the shapes that they're going to be feeling in the more complicated tactile images. We've then made this selection of 10 different tactile images of 10 really, really different galaxies. You can see here that we've got everything from sort of spiral galaxies like the one I showed you to galaxies that look really smooth and really plain. There's a lot of variety here, but we can use all of these different galaxies to basically start talking about what gives galaxies their shapes. We can talk about some of the physics that makes galaxies the way that they are. We can sort of compare things to our Milky Way or show examples that are really, really different. When it comes to talking about color, we've actually settled on a slightly unusual solution. So obviously getting across a full color image in tactile is a little bit complicated, but we're actually lucky because the way telescopes view space, so a telescope can't see color. A telescope can only collect light. And so the way we actually see color when we look into space with a telescope is we use a filter. And that filter will actually isolate particular wavelengths of light. And so if we want to see blue light in an object, we use a blue filter. If we want to see red light, we use a red filter. The way we actually make our color images is we stack those filters together. And so for us to talk about color, it actually made sense for us to break the images back up into those individual sort of filtered images. And so on the left-hand side, I have a red light filter image of our galaxy. On the right-hand side, I have a blue light filter image. And hopefully by looking at that, you can see just how different those two filter images are. They really do pick up different features. And so we can use images like this to also talk about the colors that we see in these galaxies and what that's physically telling us about what we see. Okay. Last but not least, I said that it was really important for us to sort of share the resources that we've made. So on our website at the moment, we have all of the tactile models that we've made. If you have a 3D printer, you can download those, you can 3D print them, you can use them. But we've also provided that the code that we used to make these images. So this code is pretty simple to use once you get it up and running. It uses a free 3D modeling software called Blender. And you can put any black and white image through that code and you can make a tactile surface like the ones that we've made. So if any of you can think of ways you might be able to use that, you're more than welcome to. We've also created lesson plans, obviously, for these workshops. We've shared those so that anyone who wants to run the workshops can do that. We've also got lots of supporting documentation and blog posts that document our experiences, but also how to 3D print things, all kinds of stuff like that. We also have some training videos that we're going to be posting really soon. And yeah, that's all I wanted to share with you today. But if you do want to get in touch, if you want to access the resources, I've got some contact details for us up on the screen there. But yeah, thank you so much.